Okay, so now we're experts at calculating these friction factors that we did last class. Now we're going to tie the whole story together and learn how to use them to calculate engineering quantities. And everything's about energy for any sort of design problem you're going to have. It's all about tell me the energy I need, because energy costs something. So, right, all our formulations as engineers are to get quantities that help us calculate energy. So your classic pump problem is always going to look like this picture you'll draw a ton of times. I need some liquid. It goes through a pump. And it goes through here. Let's say there's some valve right here to regulate the flow. It goes up some certain amount. And it goes to another sort of reservoir where we're going to hold liquid. So, right, there's fluid right there at point A. And then here is fluid at point B. So the simplest description of all of this stuff is I want to get fluid That's the goal. I want to get fluid from point A to point B. Now, before I could just write down the head loss equation, but sometimes it's nice to think about how Physics 1 can describe a lot of these things. So, right, this idea of going from A to B is this idea of getting fluid through this whole piping system and getting into the other reservoir tanks. So, this is where energy comes into play, right? Because if I say right here, at a zero reference frame of height, I could go up. I know that point B, right, it's at some level of distance high. I know that there's energy involved, right? You can calculate the gravitational potential of that. All right, so let's start off with that one. It's a change in energy from here to there, right? So that's just mg to z, right? So, right, we're talking about fluid, so this is density times the volume, GEC. All of fluids is always divided per unit volume, because that makes physical sense about describing a field, and then you get okay, so that is the energy per unit volume to overcome this gravitational force. So that's some energy this pump has to provide to overcome that gravitational force. Let's think of another one that we could do, and that's, right, you could think about, well, there's also kinetic energy in terms of like velocity. So that's going to be, right, your kinetic energy, pretty similar. It's per unit volume, then you just have this 1/2 rho v squared. There's also pressure work, which I always like to remind myself. So if you remember that the work can be thought of as pressure times a volume. So work equals pressure times volume. That's a thermodynamic relationship that you learn. And it's boundary pressure, boundary energy. Okay, so you just divide these. And then I always forget, honestly, that pressure is actually, you could think of it as pressure is an energy per unit volume. So that's why it shows up in Bernoulli's equation, which I'll go over next.